Welcome to today's video. We are diving into our first topic, solving linear equations on the digital SAT math section. We work through several examples and I'll guide you through different types of linear equations you are likely to encounter on test day. We also explore how these equations are applied in real-life situations. A quick introduction before we begin. I am Tim, a math educator with nearly 20 years of experience. I've had the privilege of helping hundreds of students achieve top scores on SAT Math, AP Calculus, and IB Math exams. Ready? Let's jump into our first example. The first example in the equation below, what is the value of x? 4 times the quantity x plus 3 minus 5 divided by 8 equals x times the quantity 6 times 2 minus 7 divided by 2. Let's begin by simplifying the left-hand side. First, we apply distributive property in the numerator. Multiply 4 by both x and 3, which gives 4x plus 12. Then subtract 5 to get 4x plus 7. So the left-hand side becomes 4x plus 7 over 8. On the right-hand side, simplify the parenthesis. 6 times 2 equals 12, then 12 minus 7 equals 5. So we have a 5x over 2 on the right-hand side. Now, both sides of the equation are simplified. 4x plus 7 over 8 equals 5x over 2. Let's eliminate the fractions by multiplying both sides by 8, which is the least common denominator over 8 and 2. Multiplying the left-hand side by 8, the 8 in the denominator cancels out, leaving us with a 4x plus 7. Multiplying the right-hand side by 8, we get 5x over 2 times 8, which simplifies to 5x times 4, resulting in 20x. So the equation becomes 4x plus 7 equals 20x. To isolate the x terms, we subtract 4x from both sides of the equation. That leaves us 7 equals 16x. Finally, to solve for x, we divide both sides by 16. That gives us x equals 7 over 16. The second example, if 5, 6x plus 1/3 y equals 7, what is the value of 10x plus 4y? To simplify the equation, let's eliminate the denominators by multiplying every term by the least common multiple of 6 and 3, which is 6. 6 times 5 6x equals 5x. 6 times 1/3 y equals 2y. And 7 times 6 is 42. So the simplified equation becomes 5x plus 2y equals 42. Let's look at our target expression we need to find, 10x plus 4y. Notice that we can factor out 2. So 10x plus 4y equals 2 times 5x plus 2y. Since we already know from our first step that 5x plus 2y is equal to 42, we can substitute this value directly into the factored expression. So 10x plus 4y becomes 2 times 42, which is 84. The final answer is 84. By first simplifying the initial equation and then recognizing the scale relationship between the two expressions, we are able to solve the problem efficiently. Next example, if 10 minus 3 times quantity 5 minus 2x equals 25 minus 6 times quantity 5 minus 2x, what is the value of 5 minus 2x? This equation isn't asking for x directly. Instead, it's asking for the value of 5 minus 2x. You could solve it by distributing the terms, combining like terms, and solving for x, and then substituting back to find 5 minus 2x. But that involves more steps and increase the chance of making mistakes. If we look closely, we see the same expression, 5 minus 2x, appearing twice in the equation. We are asked to find its value directly. So let's treat the 5 minus 2x as a single variable. Let's collect the 5 minus 2x terms on one side. We add 6 times the quantity 5 minus 2x to both sides. Simplifying this becomes 10 plus 3 times quantity 5 minus 2x equals 25. Next, subtract the 10 from both sides. This becomes 3 times quantity 5 minus 2x equals 15. Finally, divide both sides by 3. Therefore, the value of 5 minus 2x equals 5. By solving directly for the expression 5 minus 2x, we avoid extra steps and reduce the chance of errors. Next, let's look at an example to figure out at what point two different companies charge the same amount for a ride. Company A charges $1.50 per mile plus a $10 flat fee. Company B charges $1 per mile, but with a higher flat fee of $15. While Company B has a lower per mile rate, their flat fee is a little higher at $15. We want to find out how many miles you need to drive so that the total cost from both companies is exactly the same. First, let's define some variables. Let C be the total cost and X be the number of miles driven. For Company A, the cost can be written as 1.5x plus 10. For Company B, the cost is 1.0x plus 15. To find out when these costs are equal, we set them equal to each other. 1.5x plus 10 equals 1.0x plus 15. Next, we solve for x. Let's get all the x terms on the one side and the constant terms on the other. We subtract 1.0x from both sides, and then we subtract 10 from both sides. We have 1.50x minus 1.0x equals 15 minus 10. This gives us 0.5x equals 5. Finally, divide both sides by 0.5 to isolate x. So x equals 10. This means that at 10 miles, both companies will charge the same total cost. But wait, the question also asks for the actual cost at this point. We need to plug x equals 10 back into either equation. Let's use Company A's formula. So 1.5 times 10 miles plus the $10 flat fee, that is 15 plus 10, which equals 25. So for a 10-mile trip, both Company A and Company B will each charge $25. All right, we've just wrapped up the first part of linear equations in our digital SAT math prop series. As a quick overview, the math section of the digital SAT focuses on 4 major areas: Algebra, 13 to 15 questions; Advanced Math, 13 to 15 questions; Problem solving and data analysis, 5 to 7 questions; Geometry and trigonometry, 5 to 7 questions. In the next videos, we'll dive deeper into each of these topics. I'll walk you through key concepts, smart strategies, and real SAT-style practice problems. The goal: to help you build confidence, sharpen your math skills, and develop test-taking strategies that actually work. Thanks for watching, and I'll see you in the next one.